Hi, this is Ali and we are learning Windows System Security Hardening. In this module we are going to cover credential hardening. Credential hardening starts with credential caching. Cached credentials are stored in the Security Accounts Manager (SAM) database, and can allow a user to log on to a workstation they have previously logged on to even if the domain is not available. To reduce this risk, cached credentials should be limited to only one previous logout. Attacks that steal credentials. Learn about the different types of attacks that are used to steal credentials, and the factors that can place your organization at risk. The types of attacks that are covered include: Pass the hash, Kerberos pass the ticket, Kerberos golden ticket and silver ticket, keyloggers, shoulder surfing. So we got a demo machine set up here. And what I'm gonna do with this machine is sort of pretend to be an attacker. So there are tools out today which do what I'm going to do, which is very effective to dump the process memory. Which is exactly what I'm going to do here. So I've selected LSAS, the local security authority, and I've dumped that process. So there we go. So I've got all of the goodies right there. And then what I can do is load up a handy hex editor and simply open this process dump. So there we go. We've opened the process dump. So the next question I really have to answer is, what am I looking for inside this process dump? And what I'm looking for is my logged in user's password hash or anything else like that. So I'm logged in as Joe. Joe is an average user and he has a really terrible password. So what I'm looking for now is the hash of Joe's password. So what I've done here is I've created the MD4 hash of the Unicode of Joe's password. So, what I'm gonna do is simply take this hash and go see if I can find it in the LSAS memory that I captured earlier by simply dumping it from Task Manager. So, we go into our hex editor again and simply look for these hex values. See if I can find it, and there we go. So now Joe's in big trouble. Because if I were an attacker on the system, or I had installed some attacking tools or some malware and got administrative access, I could have dumped LSAS's memory and gotten Joe's password hash, which now makes Joe vulnerable to pass the hash attacks. And that's essentially, in a nutshell, credential protection strategies. This part of the guide helps you consider the mindset of the attacker, with prescriptive guidance about how to prioritize high-value accounts and computers. You'll learn how to architect a defense against credential theft. Follow these guidelines. Establish a containment model for account privileges. Harden and restrict administrative hosts. Ensure that security configurations and best practices are implemented. Technical countermeasures for credential theft. Objectives and expected outcomes are covered for each of these countermeasures. Use Windows 10 with Credential Guard. Restrict and protect high-privilege domain accounts. Restrict and protect local accounts with administrative privileges. Restrict inbound network traffic. Create hardened and restricted administrative hosts. Although inconvenient, separate hardened workstations dedicated to users who have high-impact administrative credentials may be required to provide a host with a level of security equal to or greater than the level of the privileges entrusted to the credentials. Maintaining security against a determined and talented adversary may require additional measures, such as verifying that all media in a build are clean to defend against malware installed in a master image or injected into an installation file during download or storage. Security baselines, which you should use as starting configurations. Use the Microsoft Security Compliance Manager (SCM) and System Center Configuration Manager to configure the baselines on the administrative hosts. The Unified Extensible Firmware Interface (UEFI), with Secure Boot and Measured Boot to defend against attack. App Control to ensure that only authorized administrative software executes on the administrative hosts. Device Guard provides comprehensive administrative control over software execution on devices. Disk encryption to defend against physical loss of computers, such as administrative laptops used remotely. USB restrictions to protect against physical infection vectors. Network isolation to protect against network attacks and inadvertent administrator actions. Host firewalls should block all incoming connections except those explicitly required and block all outbound internet access. Anti-malware software such as Windows Defender to protect against known threats and malware. Conducting attack surface analysis to prevent introduction of new attack vectors to Windows during installation of new software. The Attack Surface Analyzer helps you assess configuration settings on a host and identify attack vectors that software or configuration changes introduce. Here we can see that we have a certificate template that I've already created. And this template itself describes the certificate which will be deployed with the Audit we're interested in. This template is also restricted so that only privileged users can enroll with this certificate. If we allowed anyone to enroll in the CredGuard workstation off certificate, then they can craft their own cert without a CredGuard bound key, and break some of the trust. We are trying to build in CredGuard machines. So I've got my domain set up with the certificate template, so the next step I need to take is to log into my workstation which has CredGuard enabled as an administrator. So, I'm now logged in as an administrator. And I simply go to the command prompt and use a tool we've had in Windows for a while called CertRec. And in CertRec, starting with Windows 10 1809, we added a new switch called Enroll CredGuard Cert. And what this is going to do is take my new template I created, create a private key that's bound within CredGuard on this machine and then request a certificate with it. And once I've requested this certificate, the machine will remember it, and from this point on, every time I reboot, the machine will actually authenticate with this certificate. If I have a user that's restricted to devices with Credential Guard, then when I sign on to a device with Credential Guard, it will do what we call an armored Kerberos authentication request to the domain controller. When the domain controller looks at the user account, it sees, hey, this user has an authentication policy which says that you can only get a ticket granting ticket or an initial auth if the device has Credential Guard. So it looks at the Armor identity, and it sees that the Credential Guard Universal Security Group is there. And at that point, it allows the authentication. Now, if this user decides to sign on to a different device, so let's say they've forgotten that this is a privileged account, they're not supposed to sign on. They go ahead and sign on to Windows on this device without Credential Guard. So remember that secret like the username password is potentially, they have, but when you try and do the armored request to the domain controller says, okay, this user account can only sign on if it has Credential Guard on it. Looks at the Armor identity for the device and sees that device does not have the Credential Guard Universal Security Group, and it fails the authentication. We're gonna go back and take a look at our domain controller and start setting up an authentication policy so that we can lock down Joe, our Ali or any user, to only be able to log in from Credential Guard devices. So you'll want to start from the Server Manager dashboard and load up the Active Directory Administration Center. And then from here, you can manipulate authentication policies. So we're just gonna go ahead and make a new one. So we'll just call this one CredGuard for brevity, and we're going to add user Joe to the account list, because he's the one we want to restrict. So, we'll go find Joe, and so now this authentication policy is applied to Joe. Next up, we'll want to manipulate how Joe can sign on. So, we wanna restrict him to our CredGuard machines. The group I created is called CredGuard Hosts, which means anytime a system authenticates with a CredGuard certificate, as identified by the OID, that machine automatically gets the CredGuard host SID. So by doing this, I'm now restricting user Joe, who's in the accounts list, to only be able to authenticate from systems that meet the CredGuard hosts group requirements. Your users is to allow NTLM network authentication when user is restricted. What this means is, Joe is a user who potentially has a sensitive password, so you don't want him doing NTLM authentication. However, you may think it's okay for Joe to do NTLM authentication when he's coming from a CredGuard device, because you have a high assurance that his credential is protected. And there's one last setting I want to take a look at before we save this policy, and that is the audit versus enforcement switch. For purposes of this demo, I'm sure it's going to work, so we're gonna go straight ahead and enforce the policy. So now I've created a CredGuard authentication policy. And this means that Joe, my user, can no longer log in from a non-CredGuard device. And that's exactly what we have here, is a device that does not have CredGuard enabled. So I'm going to type in Joe's PIN and sign in with a virtual smart card. And the domain controller will instantly deny my access, because Joe's account is configured to only be able to log in with CredGuard devices. So let's go back over to the machine we set up earlier with a CredGuard certificate. I'm going to log Joe in here and he will be granted access, because this system has authenticated itself using the certificate that the Credential guardoid, which then mapped to the Universal Security Group, which satisfies the authentication policy.